So we'll be learning about distribution models today. Now, whenever we have a lot of data or data that is about to increase in a database, it becomes impractical to use only a single server, which may make the cost higher. It will basically increase the cost and it will become inefficient. So in that case, we can use another model where it's called a distributive model or a distribution model, where you use a cluster of servers. Actually, you use a cluster of servers in order to store the data. So there are two methods in using a distribution model: replication and sharding. And you have to understand, it's more efficient to always scale out rather than scale up. Scale up will always be practically impossible at a certain limit, and scaling out, as of now, it doesn't have any limits. That's what it is. So let's talk about the two distribution models. The first one is replication and the second one is sharding. Let's talk about replication first. Replication involves making identical copies of same data and placing them on multiple nodes within the cluster. This approach provides benefits like increased data capacity, better handling of read and write requests, and improved availability in case of network issues. There are two common types of replication. Well, the name itself suggests that it will basically have multiple copies of the same data across multiple nodes or multiple servers inside the cluster. What this will do is it will let us have better handling of read and write operations. It will give us more storage capacity, and it can also secure our data basically, because if one server fails, the data will still exist in some other server. We'll basically introduce redundancy with this. So in under replication, there are two types: master slave and peer to peer. They are very simple. Master slave is also using a cluster of servers, but here one server is the master server. Only this master server can basically perform all the write operations. The other slave servers, all they can do is read. That's all they can do. And now the peer to peer. In peer to peer, it's basically completely contrast to the master slave, because every server has the right to both write and read, perform both read and write operations. They balance the workload, basically. They balance the workload by distributing the data across different servers. And that is what replication is. And the sharding is less complicated compared to replication, because sharding is nothing but whenever we have an really big data set, whenever we have an extremely large data set, if we want to, we can usually use sharding so that we can split the same data set into multiple pieces. It's like basically breaking down the same data set into different pieces, and then it will be stored across different servers. So let's say we have a 10 GB data set, for instance. Then 3 parts of it will be stored in different servers. The one will have 3 GB, one will have 4 GB, and one will have again 3 GB again. That's how sharding works basically. It doesn't replicate, it just basically breaks down one big data set into several pieces. So this is how we basically perform distribution on our data, on our databases. It's important to know that we can use either replication or sharding, or we can use both sharding and replication together. But they have their own disadvantages of using only this or only sharding. Only replication can cause so much redundancy, so it can require a little bit more space. But it will give us a lot of fault tolerance. That is, if one server fails, we can still rely on another server for the data. And then there is sharding. Sharding is specifically only used for large data sets. It doesn't really get more complicated or easier than that. It just basically takes a large data set, it divides the data set, and then it will store it across different servers. That's it.